Okay, in this question, we're going to be looking at minimizing the cost of laying cable in different scenarios. So let's go through the question and then kind of see what's happening. So, a cable television company is laying cable in an area with underground utilities. Two subdivisions are located on opposite sides of Willow Creek, which is 100 meters wide. The company has to connect points P and Q with cable, where Q is on the north bank, 1,200 meters east of P. It costs $130 per meter to lay cable underground and $260 per meter to lay cable underwater. What is the least expensive way to lay the cable? And then we're gonna find how much it'll cost too. Okay, so what's happening here? Well, let's say we're starting at Q and going to P. You could do it the other way too. You go from P to Q, like it'll should end up the same, right? But I'm gonna make my picture this way, where there's two scenarios where you can go from Q, and we could go like all the way down here, and go like on land, right? We could actually dig in or put our layer pipe in like underground to that point, okay? And that's less expensive. It's only $130 per meter, and then comes straight across the river, right? The problem is that's a lot more pipe, right? So that might be more expensive. And then another option is that they could go just straight across the river from point Q to point P, but that's expensive. $260 per meter to do it that way, right? So what we're assuming is that there's some sweet spot where we're gonna lay the ground or lay the pipe along the ground, maybe to here, and then turn and come across the river. Okay, so let's call this distance, we'll call this distance 1, so D1. I'm going to call this distance 2, so D2. Okay, now, what we're going to do next, let's turn this into a little right angle triangle. See if we can make some sense of this. And we know some of these things. So we know, well, this side of the triangle is 100. And I'm going to call this length right here, I'm going to call this X. Okay, so that's, so that's X to that point. And then this point up here, my D2, well, that's really going to be 1,200 minus X. Okay, and that would make up the whole thing. And then when I start doing my equations here, we're going to be in terms of X. Okay, so that's where we're starting. So now let's find an expression for D1 based on X and 100 here. So just using Pythagorean theorem, right? We can solve for D1. So in that case, what we have is D1. I'll write that in blue. D1 we would get from finding, so it would be D1 squared is equal to X squared plus 100 squared. That was strange. Okay, and then if we just continue on with our Pythagorean theorem, we get the square root of X squared plus 10,000. Okay, so that's what D1 is from now on, right? When I start adding this up. Okay, so now D2, well, actually, I already kind of did that, didn't I? D2, we said it was 1,200 minus X. So here, I'm going to put a box around that because I'm going to need that in a minute. And then D2 would be 1,200 minus X. All right, so there's a couple of equations that I have going on. And now let's think about this in terms of price. Okay, so the total price well, the total price is going to be equal to, if you think about it, it's just going to be the length of D1 times the cost, right? So and in this case for D1, it'd be the cost, or the price, let's say. Price of going through the water, so maybe price H2O, okay? And then from there, it's going to be plus, and then the price of going over land. So that would be the length D2 times the price land. All right, so we didn't really need to write all that out, right? This is more just so you can kind of picture what's happening. But then let's actually put this in. So D1 would be, well, we had that, right? So that would be the square root of x squared plus 10,000, because that is D1, times, and then the price of going through the water. So that's $260 per meter. So that's 260 plus, and then D2, we said that was 1,200 minus x. I better put this in brackets because now we're going to multiply by the price going over land. So 130. All right, so that is my equation. So just like in the other ones where we ended up finding an equation and then we had to take the derivative of it, that's what we have going on here too, right? So this is my equation. I'm just going to have to take the derivative. So why don't we simplify this up a little bit first, though? So it's a little bit easier to take the derivative of. So this would also be equal to, and I'm just going to write the 260 in the front. So 260. I'm going to rewrite the square root as, so it'd be x squared plus 10,000. And then instead of square root, it'll be to the power of 1/2. Just so I can easily take the derivative here. And then plus, we can expand the 130 in. So we get 156,000 minus 130x. All right, so I think that's about as good as we're going to get before we take the derivative here. And just to give it a symbol, maybe I should have said p. Just carry on. This is like my function p for price. And then from here, we're going to say p prime. So we'll take the derivative now. Okay, so how do we take the derivative of this? Well, this is really a chain rule, right? So I'm going to bring down the 1/2. So it's really like 260 divided by 2. So this becomes 130. And then I'm going to multiply it, still like keeping my original function. So I still have x squared plus 10,000. And now this was to the power of negative 1/2 though, right? Because I had to subtract 1. And then plus, and then all of this would become, oh, sorry, I missed one step. So this was that part, and then we still have to take the derivative of the inside. So I almost forgot the chain and the chain rule, right? So the inside here would just be 2x. And then minus, and then the derivative of all of this is just 1, so minus 130. There you go, so that is my derivative. So now if I want to minimize this, well, just as a quick little sketch, what we're after here is that my price would be like on my y-axis, and my x would be, that I'm graphing, would be this x, okay, in my picture. And I'm expecting that this thing is going to do, if it's a minimum, I'm going to be doing something like this, and I want to find my minimum value. So I'm going to set the derivative equal to 0. That's where it's flat. So I'm going to say 0 is equal to, and then let's just write this a little bit different now without the negative exponent. So this would be 260, right? I'm multiplying 130 times 2, so 260 x over, and then I'm going to write this back as a square root. So square root x squared plus 10,000. And I still have minus 130. All right, so now all I'm going to do is I'm just going to take the 130, bring it over to the other side. So we have 130 is equal to 260x over the square root of x squared plus 10,000. We'll bring the square root up. 130 times the square root of x squared plus 10,000 is equal to 260x. So now let's divide both sides by 130. So we have the square root of x squared plus 10,000 is equal to 2x. And then now at this point I need to get rid of this square root. So I'm going to square both sides. So square both sides. So x squared plus 10,000 is equal to 4x squared. subtract x squared from both sides, or just bring this one over here. 10,000 is equal to 3x squared, just subtracting there, and then divide both sides by 3. So we get, and maybe in the same step here, since it's squared, I'm going to take the square root. So we have the square root of 10,000 over 3 is equal to x. So then x is, and we can make our little squiggly equal sign, which will be more approximately 57.7. And then this was meters. All right, now, just let's not lose track of what we actually just found, right? That number was this. That was our x value that we were solving for there, right? So now from that, we have an equation. So we can actually say what the price will be. Like, we know where to turn. We can figure out exactly how far we should go down the shore before we turn, right? Because it'll just be 1,200 minus 57, right? That'll tell us where we need to turn across. But now let's do the work of actually figuring out how much it would actually cost, right? So let's just go back to our original equation here. So the price would be equal to, and it'd be the square root of 57.7 squared plus 10,000 times 260. And then what was the rest of our equation there, right? So this is what I just put in, right? I just put in our number for x there. And then plus 1,200 minus x. And this should be in brackets. Times 130. Okay, if we put all that in, we get $178,000, 516.66. So that would be the total. That'd be the cheapest way to do this, right? Is what we just found.